Alright, Math 3. So we've got a lesson on multiplication and division of rational functions. So first thing, do this warm-up. It's on page 27. Okay, take 2-3 minutes, maybe even 5. So have the guest teacher pause the video right now and get this one done. Alright, so hopefully you had a second to do that. So it says the area of a rectangle is the product of its length and width. So, right, if we draw a rectangle, it's the length times the width for the area. So, if its length is 7/8 centimeters and its width is 2/3 centimeters, well, then we just go 7/8 times 2/3. Now, the nice thing about multiplying with fractions, and which is what we'll apply in the rationals, is that we don't have to get common denominators. We just multiply the top and multiply the bottom. So 7 times 2 is 14. 8 times 3 is 24. And we do need to simplify a bit, okay? Now, an easier way to simplify would have been to realize that 8 is really 2 times 4, and that those 2's would have canceled, leaving us with 7/12 for our answer. Okay. Now 17 says a square has a perimeter of 17 centimeters. What expression represents the square's area? Well, if we think of a square, it's the same length across, right? So if I go 17 divided by 4, that would give me its perimeter. Okay. So if we were to get that area, we would just times 17/4 by 17/4. Okay. Which would give us 16 on the bottom. And then 17 times 17 is, I don't know that one off the top of my head, so 289. Which, I don't know if there's a number that can go into both. I don't think there is. We'll call that good. Okay, 3 says, another rectangle has a width of x/2 and a height of 3/4. What expression represents this rectangle's area? So just x/2 times 3/4. So we'd get 3x/8. Can't simplify it, so we'd call that good. Alright, so let's keep going in the workbook. So turn over to your next couple of pages to example 1. First we're going to just deal with multiplication of rationals. Then we're going to delve into division. Now the division sounds really bad, but it's actually not so bad. Okay. So, and the main concepts are we just try to simplify and multiply, okay? If it's on the top, then it's on the bottom, then we can eliminate it, okay? So, on this first one, if we don't have a fraction, we can always make it a fraction by putting a 1 under it. Then I'd multiply the top, 3 times 8 is 24, over, we'd multiply the bottom. 1 times x plus 1 is x plus 1, okay? So, that one was simple enough, right? Okay, just to kind of get our brains a-moving. Alright, same idea if it's 5x. We make it 5x/1. Okay, now there's 2 ways we can deal with this one. Okay, I'll show you, I guess, the longhand version first. So we would multiply across, get an x on the bottom. X times 5x would be 5x squared. Negative 3 times 5x would be negative 15x. Okay. Then maybe I would realize that each term here has an x. So I could pull out an x and have 5x minus 15 over x, and those would cancel out. Okay. Or, this is kind of how I like to think of it. Okay. Is because I'm multiplying, it's essentially like I'm just bridging this gap, okay? So I see an x over here and an x down here. I'm going to cancel those out, and then it's just 5 times x, which is 5x. 5 times negative 3, negative 15, over 1. So we just leave it like that. So I like to kind of try to look ahead and see what I can eliminate to begin with. Alright, let's take a look at example 3. Okay, now we've got 2 fractions here. Okay, so again, I would look, is there anything I can eliminate across or even vertically? There isn't, right? So we just multiply across, making sure to distribute that 5. 5 times x is 5x. 5 times 1 is 5. Over x times x squared is x cubed. Can't simplify that any further, so I call that good. Okay, so that's really all there is to it. So the trick really comes down to is just recognizing what's going on here, okay, and recognizing if there's anything I can eliminate. So if I look at this one, it's like I could draw that fraction as 1, and you can put parentheses around each piece and realize this is just what you're multiplying. So there's nothing I can really eliminate here. It almost looked like we could eliminate these two, but there's a minus and a plus and just regular x's, so I can't even pull out a negative 1. Okay, so I just multiply across. So x times 2x, 2x squared, x times negative 3, negative 3x, 1 times 2x, positive 2x, 1 times negative 3, negative 3, over x squared times x, x cubed, x squared times negative 1 would just be negative x squared. Okay, now we can simplify some things. 2x squared, negative 3 plus 2 would just be negative x minus 3 over x cubed minus x squared. Okay, now if I look at this, there's not really anything else I can do here, so we call that good. Sometimes there is more that you can do. Alright, so example 5, okay, now we're getting a little more complex, okay, and whenever we're given these quadratics, I like to factor them, okay, to simplify them, because often there's stuff we can eliminate. Okay, now, we could, if we really wanted to, just start off and multiply these across the tops and bottoms. Okay, but that's pretty ugly looking, so I'm going to, instead, like I said, we need to factor, just kind of with the addition and subtraction and simplifying, that factoring comes into play. So, let's factor this first one. So I've got a negative 5, and x squared, and I want to know factors of negative 5 that would add up to negative 4. Well, the only factors are 1 and 5. To make a negative 4, the 5 would have to be negative. So negative 5x and a 4x. Okay. Not a 4x, a 1x. What was I thinking? So that's like negative 5 times 1. So we can factor out a negative 5 and factor out an x. And we can factor out our second x and factor out a 1. It's positive, so it's plus. So I get x plus 1 over x minus 5 here on the left over x plus 1, which I should notice right off the bat, I can eliminate that. Okay? So, we got x plus 8 here. So let's factor this one and see what that gives us. So we've got x squared and 8. Okay, factors of 8 that would add up to 9. 1 and 8, or 2 and 4. It's going to be 1 and 8. So 1x, 8x, so that's like 8 times 1. So I can pull out a positive 8, pull out 1x, pull out a 1, it's positive, and pull out my second x. So on the bottom here we get, again, x plus 1 times x plus 8. Now these x plus 8s can eliminate, so I'm left with x minus 5 over x plus 1. Because that's what's left over. Okay, now I could have tried multiplying them to begin with, and then trying to factor, and I could have got that same thing. But if I would have done that, it would have looked something like this, and this would have been very difficult to notice the differences over I'm multiplying these ones now. Because it's x plus 1, it's pretty simple. Okay, and then you would have simplified, getting x cubed plus 4x minus 37x minus 40. Well, that's a squared. And on the bottom, x cubed plus 10x squared plus 17x plus 8. And you would have been able to factor these down until we had that, what was it? Like x minus 5 over x plus 1? Something like that. Okay, so you can see that it would have been harder to get that out of these, so that's why I say simplifying to those factors, then trying to eliminate and multiply makes it a lot easier. Alright? Okay. So that's mainly the multiplication we're dealing with, and that's really all it comes down to. Okay? So now we're going to jump to page 39. Okay, let's do this section where we've got division. And really, division only does one extra thing. Okay? So with 3x squared over 7 divided by x over 3. Well, if you recall, we can't divide by fractions. However, if we take something that we're dividing by, like say dividing by 2, that's the same thing as timesing by 1/2. So, what we can do, and what we've been able to do with the dividing of fractions, is that we can actually multiply by the reciprocal of the second fraction. So the 3 goes up top, the x goes down bottom, that changes that to multiply. Then we can deal with it. Okay? Now, one thing to note. Back here, we often tried to eliminate things as we could. Okay? Before we really got going. Here, we can't. We have to flip it before we eliminate. So I can't say these 3's cancel out. Okay? Because this is division. And we can't do that with division. So, after we swap it, then yes, this x times x, this x, one of these x's can be eliminated. Okay, but the 3's aren't going to be able to. So we end up with 3x times 3, which is 9. 7 times, that would be 1, which is 7, so 9x over 7. Okay, so I can't stress that enough. You can't start eliminating till after you make the switch. Okay? Alright, so let's take a look at the example 2 now. So once again, first thing I need to do is I need to swap that. Okay. Now, for sake of being lazy and not wanting to write a ton, there's some ways that I can do that easier. So I'd write my first one out, then times, then this 5 we put on the bottom. I'm going to factor this before I rewrite it, because I know I want to factor that. So, if possible, so a 1 here, but I don't think this one's going to work, is it? Because the factors of 1 that would add up to -1, you can't have. So that's not going to work. So I guess we're going to be stuck just multiplying here. So we multiply by x, giving us this over this. That's actually all I can do. I can't simplify that one further. Alright, let's try number 3 now. Okay. Alright, so, and I like to simplify as I go. So like this one, x squared minus 3x. They share an x, so I'd be able to pull an x out, giving me x minus 3 left over. Then we factor that. So -6, x squared. So factors of -6, it would add up to -1. Well, 2 and 3 or 1 and 6 are our only options. So if 3 were negative, that would add up to a -1. So 2x, -3x. This is really 2 times -3. Pull out a -3. pull out an x, pull out the second x, pull out a positive 2. So this would be x minus 3 times x plus 2. So we can see kind of some benefits of doing that right off the bat, is that now I notice I can eliminate those two, right? Okay. Then we're going to multiply by x plus 2, because we got to, instead of divide, we got to multiply by the reciprocal, x minus 3. So the x plus 2's eliminate. So on top, all we have is x. On bottom, x minus 3. And that's as simple as we can make it, people. All right. Okay, last example here. All right, so even though this looks super complex, let's just break it down a piece at a time. So first, let's deal with this one. Okay, factors of 14 that would add up to 9. That's going to be 2 and 7, right? So 2 times 7, 2x, 7x, x squared. So we get an x, positive 7, positive 2, and an x. So we'd have on the top here x plus 2 times x plus 7. Okay. On the bottom, they each share an x. So if we distribute out an x, we'd have x plus 7 times, since it's division, make sure we flip this. So we've got a 4 and an x in each of these. So we would pull out a 4x, and we'd be left with an x minus 1. Then we need to factor those. So factors of negative 2 that would add up to a positive 1. It'd have to be a positive 2 and a negative 1. So a negative 1 times a positive 2. So pull out an x, pull out a negative 1, pull out an x and a positive 2. So on the bottom here, we get x minus 1 and x plus 2. Okay. Then I look on top and bottom. Now, because we're multiplying, we just start eliminating things. Okay. X plus 7's eliminate, x plus 2's eliminate, x plus 1's eliminate, and finally the x's eliminate. And so all we're left with is a 4 over 1, or just a 4. Okay, so the main things to pay attention to is that whether it's multiplication or division. If it's multiplication, you just simplify, eliminate what you can, multiply what's left over. Division, you have to make sure that you're flipping the second inequality. Okay, so homework for today, or you should have plenty of time in class to work on these. Okay, pages 33 and 43. Just do 1 through 5 each. Okay, and these will be due when I come back. Okay, but I think this is simple enough that you guys should be able to work on this on your own. So next class, I know I said I was going to do something with graphing, but I'd rather not jump that far ahead on second thought. So I think that on Thursday you'll have a practice day. So you'll just come and you'll have a worksheet, and you'll just be multiplying and dividing, and I'll have a video ready so that you guys can utilize that video as well to help you out with that. So basically you just need to get started on this, get it finished. If you need some help, I have a video made up for the homework, both of them, that should already be on YouTube and my website. So if you get stuff done and you want to double check your answers, ask the guest teacher if you can take a look at it either on your own, or you can show the whole class if everybody's finished. And then come Thursday, ready to practice some more, so make sure you do the homework over and are ready to go on Thursday, so you come into class and you can work together, do some problems, watch some of the examples, make sure you guys stay up to speed on things. So, and then it'll all be due when we're back. So, well, when I'm back, because you're already back. So we'll just, and we'll go over any questions you may still have about the multiplication and division. And I think that should be pretty good, so you should have plenty of time to get to work and get things done.